Hello, guys. Let's continue our discussion about nodal analysis. So we discussed like in last video, like some basic nodal analysis like circuit. And this time we're gonna make it a little bit more complicated by adding like a dependent current source, like this guy here. Okay, this guy is a dependent current source, and by dependent I mean its value is the current it produces. It depends on some current in some other like branch. In that case here, Ix, the current that produced by this guy, is equal to I. Where is I? I is the current flowing in the 6 ohm resistor. I here. Okay. So if the current flowing in the 6 ohm resistor, for example, 5 amperes, then Ix will be 10 amperes and so on. Okay. So it's the same solution or the same methods that we or the procedures that we follow to solve the circuit using the node analysis will be exactly the same. Also here, because we have like another unknown, which is basically Ix, so we're gonna have like one more equation, you know. So that's basically because you have now three, for example, three unknowns, so you're gonna have like three equations to solve it. Okay, so exactly the same procedure. Okay, so let's follow. Let's go to the white color here. Okay, so what we did before, so we first, as we discussed, we search for the nodes that has like three branches. Okay, so here we have a node that has three branches. Let's mark them with red. So this is a node here. Let's call it V1. There is another node here that has also three branches or more. Let's call it V2. And this guy here, let's call it V3. The second step is to assign one of these nodes a ground. We can do this for V1. We can do this for V2. We can do this for V3. Usually people choose like the bottom node to be like the ground. It has no rule. Okay, so but whatever you like. So for example, I'm gonna choose here V3 as a ground. We're gonna get the solution. Try the same, but using V1 for example, and you should exactly get the same solution. Okay, so let's continue here. So the third step is basically to choose like one of the nodes and try to solve Kirchhoff current law at that node. So let's start by V1. So we assume all the current at V1 is going out of V1. So current like that, we have I already, and a current like that. Okay. Let's call them, for example, I1, I2, and we have I. So I1 equal to, so I1 flowing or leaving V1 and going to that node here. Okay. What is the voltage of that node? Let's assume we don't know. So we have here a battery. This battery produces 5.3 volt. If you have a battery, it's two nodes, V1 and V2. Okay. And then or let's call it V minus and V negative. So this is V minus, this is V positive, and the battery voltage is E. So E is equal to V positive minus V negative. So that's exactly what we're gonna do here. So we have here 0, and we have here, for example, V. So V minus 0 equal to 5.3. So V is equal to 5.3. So I1 is equal to V1 minus 5.3 divided by 4 ohms. Okay, the resistance. The voltage difference divided by the resistance value. Okay, I2 is leaving V1 and going towards the ground V3. So it's equal to V1 minus V3, which is 0, divided by the resistance, which is 3 ohms. And I equal to, I is leaving V1 going to be V2. So it's V1 minus V2 divided by resistance 6 ohms. Okay, that's good. So Kirchhoff current law says the summation of all the currents leaving a node is equal to 0, or going into the node equal to 0. Or you can say the currents going into the node equal to the summation of current going out of the node or leaving the node. Here, all of them is going out of the node. Okay, so I1 plus I2 plus I equal to 0. Okay, so in that case, V1 minus 5.3 plus V1 over 3 plus I, which is V1 minus V2 over 6 equal to 0. So now, which let's take V1 as a common factor. So 1 over 4 plus 1 over 3 plus 1 over 6. Then we have V2. V2 will be 1 over 6. Okay, equal to, I'm gonna get the 5.3 over 4 to the right hand side with positive sign. So 5.3 over 4. That's exactly the shape that we expect for this equation at V1. V1 multiplied by the summation of the reciprocals of all the resistances connected to it, minus V2 divided by the resistance between V1 and V2. If there is V3, it's going to be V3 minus V3 divided by the resistance between V1 and V3. If there is V4 and so on. Okay? Equal to the current source value or equal to the voltage source value divided by the resistance. Okay? Good. Now, this is basically equation 1, but let's simplify it more. So I'm gonna use here the online calculator. So V1, and this is 3 by 4. Minus V2, 1 by 6, 5.3 over 4. Okay, that's basically the first equation. Now, the second equation should be add V2. Okay? As you see, guys, we solve normally now. The dependent current source doesn't appear to the picture right now. So let's change the color. Let's go to the white. So V2. Okay. Same procedure again. At V2, we're gonna assume all the currents are going out. So let's call this guy I1. Let's call it I3 because we have already I1 and I4. I5. I5. Okay. So I3 is actually minus IX. Okay. So I3 is going from, so IX flowing in that way. I3 is going opposite. So I3 is equal to minus IX. I3 equal to minus IX. And what is IX? IX is actually 2I. So this is equal to minus 2I. And what is I? I here. V1 minus V2 over 6 equal to minus 2. V1 minus V2 over 6. Good. Now I4 is V2 minus 0. I4 is here. V2 is leaving V2 going to the ground. So V2 minus 0 over 12. I2, I4, V2 minus 0 over 2. And what is I5? I5 is minus I. So I5 is going in the resistance in this way, resistance 6 ohm this way, I is flowing in the opposite direction. So I4 is equal, or I5 is equal to minus I. So I5 equal to minus I. And what is I? I is V1. Again, we have it. V1 minus V2 over 6. Okay, so let's put all these together because all of them are leaving the nodes. So the summation of all of them is equal to 0. So this is I3, remember? So minus 2, V1 minus V2 over 6. This is I4, V2 over 12. And this is I5 minus V1 minus V2 over 6. Okay. So this negative sign here will flip V1 and V2. So here minus 2 V1 minus V2. So it can be positive, and this can be, let's make it with another color to make it very clear for you. So this can be positive, this will be negative, this will be positive. This can be positive, this can be negative, this can be positive. So from that one here, we can deduce. And this term is exactly this term, correct? So it can be 3. So 3 V1, oh, 3 minus V1 plus V2. So it's going to be V2 minus V1 over 6 plus V2 over 12. I'm sorry, this is equal. This should, all of this should equal to 0. Equal to 0. The summation of the current equal to 0. Okay. So let's continue here. So V2 as a common factor will leave us with 3 over 6, which is half, plus 1 over 12, minus V1, oh, minus 3 over 6, 3 over 6, equal to 0. Okay? And that's equation number 2. Okay, so let's now solve these two equations together. Okay? So last time we used the ChatGPT to solve these two equations. I'm gonna use today another tool it's a free tool. It's called Desmos. It's an online calculator, but it has another version that can do what's called matrices, matrix multiplications. So this is basically the default. Just write Desmos on, on Google. It's gonna give you this website in here. Then go to the math tools at the top and choose matrix calculator. Okay. So we're gonna just follow the steps. If you didn't learn or like take a course on linear algebra before, this might looks weird for you, but it's basically very basic linear algebra, calculations. So if you didn't take this course before, just to follow the steps. It's very easy. So we're gonna define a matrix called A. So just click A here and click new matrix. Here we have two equations, two unknowns. So we need for A 2 rows and 2 columns. 2 rows and 2 columns. 2 by 2 matrix. Okay. In the first row, I'm gonna put the coefficient of V1 and V2. So 3 over 4. Then the right arrow again to go to the next element, and then minus 1 over 6. Don't forget the minus for V2. Minus, we can show minus 1 over 6. Then the down arrow, left arrow, go to the second row. Now we should put the coefficient of the second equation. But here in the second equation, remember V2 is the order matters here. So V1 should be always because in the first equation or first row, we put the coefficient of V1 first, which is 3 over 4. So we must do the same for the second equation. So in the beginning, we're gonna put minus 3 divided by 6. Then the right arrow 2 times to go to the next element. Next element will be the coefficient of V2 in here. And you don't need to simplify this. You can just write it as it is, which is the beauty of using Desmos. 3 over 6, right arrow, plus 1 over 12. Okay, that's it. Then hit enter. Now we need another matrix to put what? With the right hand side. So we have here 5.3 over 4, and we have here 0. So we're going to define another matrix called B, and we hit click new matrix. Now we need just one column, not two columns. So decrease the columns by 1. So make it one column here. So in the first, we're going to put 5.3 divided by 4. Then in the second one, we put 0. That's it. Hit enter. Now we're gonna multiply the inverse matrix A by B. Again, this is linear algebra, but just if you didn't take this course, just to follow this one. So we click A, we click the -1, we multiply by B. That's it. That's the correct solution. So V1 is 2.18. Let's write this here. I have it ready. So V1, 2.18, and V2, 1.87. 1.87. Two decimal places are okay. Okay. That's basically, how to use Desmos, and that's the correct solution. Okay. Remember, we didn't finish because actually the question was to find ix, which is 2I. Okay. So find ix is the current that produced by the dependent current source here, and it's equal to 2I. So let's get that. We know I is equal to V1 minus V2 over 6. So we're going to solve this. So I here, based on that, equal to this V1, this equation V1 minus V2 over 6, 218 minus V2 1.87 over what? Over 6. Let's calculate this using Desmos. 6. That's around 0.05. So Ix, which is equal to 2I, is around 0.1 amps. Okay, guys, that was it. It's easy. It's not like something complicated. It's just you should take care of, the unknown that will be added to the circuit, which in this case was Ix. Okay. And I said in the beginning, we need like a third equation to be able to solve this. Yes, we have the third equation, by the way. That was the third equation. But I didn't want to make it like a 3 by 3 system, like 3 equations and 3 unknowns. I just get this third equation and I integrated it into the 2 equations that we already have for V1 and V2. Okay, but you can do this. You can also have like a 3 by 3, 3 equations by 3 unknowns. Okay, and it should be also easy. Okay, guys, thank you very much for watching and see you in another video. Bye-bye.